Okay, so for 1 and 2 and 3 and 4, we have to do the remainder theorem. So that means that we take the number inside of our box and use synthetic division. So we have 4, -16, 5, and then here we're missing our x value, so we have to make sure we include a 0 for x, and then 9. So we bring down our 4, -2 times 4 is -18, -8, -8, and -16 is -24. Times -2 would be positive 48. 48 plus 5 is 53. 53 times -2 would be -106. -106 times -2 would be positive 212, and then 212 plus 9 is 221. So our answer here is 221. Any questions on this one? All right, we're gonna do.
When it asks you to use the remainder theorem for it, like, I know you have to do all that, but does it want you to also plug the -2 into it just to check? Or?
I mean, if you have time to, you definitely can plug in the -2 and check and see if you did it right. But you don't have to. So if you want to, you can, just to double check and make sure you did your work right, but you don't have to do it.
Thanks.
For number 2, we're going to do the same thing. So we have a 5 on the outside. And then on the inside, we have 4, 16, -16, 5, 0, and 9. So we bring down our 4. 4 times 5 is 20. Minus 16 would be 4. 5 times 4 is 20. 25 times 5 is 625. Right? No. It is 125. 125 times 5.
Yeah, it's then 600.
Then it's 625.
Yeah.
And then plus 9 would be 634. So our answer for number 2, 634. For 3 and 4, we're doing the same thing. Do you guys want me to do one of those, or are you ready to move on?
You can move on.
Everybody else okay with that? All right, let's look at number 5. So we need to find all the roots. So we're going to do P over Q. For 5, on the test, we're not going to have one that starts with the coefficient of something that's not 1. So here our P's would be 20, 10, 5, 4, 2, and 1. And then on the bottom, we would have 1 and 3. These are all plus or minus. So here we would have some fractions that we would need to try, but we're not going to have any that have a coefficient out front that's not 1. So you won't have any like that on the test. You guys want me to work out number 5 or number 6?
Can you do number 6?
Yeah, I'll do 6.
Thank you.
Okay, so our coefficient, or our factors of our constant, we don't have a constant here, so it would be like 0. So the first thing we need to do, which the first thing we always have to do, is pull out our greatest common factor. So here our greatest common factor would be x. So then we have x to the 4th plus 6x cubed minus 9x squared minus 44x minus 30. So now that we pull out an x, this means one of our factors of this problem, one of our zeros, is going to be 0. And now we can just take care of what's on the inside of our parentheses. So we need our factors of our constant. So we have plus or minus 30, 15, 10, 6, 5, 3, 2, and 1 over our factors of our leading coefficient, which is just 1. So what should we try first here?
One.
We could try 1 first, but if you guys did this as homework, you should know that 1 does not work, right? So what else?
Yeah.
What else can we
No,
try?
3.
Let's try 3. And then inside our coefficients that we put would be 1, 6, negative 9, negative 44, and negative 30. So we bring down our 1. 3 times 9 is 18. Nope, 27. 27 minus 9 is 18. Right? Yeah. 3 times 18 is 54. 54 minus 44 is 10, and 3 times 10 is 30. So we get 0. So 3 works. So that's another one of our zeros. And now we are left with x cubed plus 9x squared plus 18x plus 10. Can we factor this?
Yes.
We can?
But can you put it into 2 separate parentheses to factor?
We can factor by grouping, but this one it doesn't work. So we would just need to do synthetic division again. So we need to see our factors of our constant, which are plus or minus 10, 5, 2, and 1, over our factors of our leading coefficient, which is just plus or minus 1. And then we need to do synthetic division again. So what can we try here? Let's try negative 1. So we have 1, 9, 18, and 10. Negative 1 times 8 would be negative 8, and this is 10. Negative 1 times 10 is negative 10, and we get 0. Perfect. So negative 1 is another 0. And now we have x squared plus 8x plus 10. Can we factor this?
You can use the quadratic formula, right?
Yes, we don't have 2 factors of 10 that will add up to 8, so we have to use the quadratic formula. So it's negative b plus or minus the square root of b squared minus 4ac over 2a. So this gives us negative 8 plus or minus the square root of 64 minus 4 times 1 times 10 over 2 times a, which is just 2. So negative 8 plus or minus, we have 64 minus 40, which is 24. And then we can pull out a 4 from 24, which would give us a 2 that we take out. And then we're left with 6 on the inside. And then we can simplify this by dividing everything by 2. So this would be negative 4 plus or minus square root 6. So our last 2 factors that we have here, our last 2 zeros, are negative 4 plus square root 6 and negative 4 minus square root 6. So if we look at our leading exponent, our highest exponent is 5. That tells us we're going to have 5 zeros. So here we have 1, which is 0, 3, -1, -4 plus 6, and -4 minus 6. So we have our 5 there.
Miss Carver,
Yes.
after doing the first synthetic division, like that first part, and then we get those numbers that we plugged into the next problem of synthetic division.
Yeah.
Is it always like that, like using new numbers, or can you use the same number used before?
It's going to be like this because now we can just narrow down what numbers we have here. So once you get a new polynomial, you have a new constant at the end, so you want new possible zeros, which it's just going to narrow down what zeros you have. So it's just going to eliminate some, because now we know 30 is not going to work, 15 is not going to work, 6, and then we already did 3, so 3 is not going to work again. So we're just narrowing down our options that we have to plug in.
Okay, so we should always do that?
Yep.
Okay.
Okay, there's one more up here that I just added. Miss Meadows thought it would be a good idea to practice for your test. So I just added this one to the review today, if you want to take a look at what's on the screen. So it wasn't on your review, but we can do it together now. So we have our factors of our constant, which is plus or minus 36. We have 12 that goes in here, 4, 3, 2, and I think an 18. I think that's it. And then
a 9 goes into.
and a 9. Perfect. And then on the bottom we have plus or minus 1. So here, when we do synthetic division, we need to make sure we include our missing numbers. So we don't have an x squared, so we need to put a 0, or an x cubed, so we need to put a 0x cubed, and then we don't have an x, so we would need to put a 0x. So inside our box, we need to make sure that we have 1, 0, -5, 0, and -36. And then what number can we try first?
Try 1.
Let's try 1. For the sake of time, let's not try 1 because I know 1's not going to work. We definitely could try 1.
Should we usually try bigger numbers?
Well, always doing 1 first is a good way to start, just because working with the smaller numbers first is easier. And then if you see it's not going to work, you can just give up halfway through if you want and try something else. So
Because I was thinking, since we have like a really big number at the end, I wouldn't think that 1 would work, since it's only multiplying with the number itself. So it wouldn't really do anything.
right. So what do you want to try here?
Like a 4.
How about let's try 3? So remember, you could try any one of these numbers here, and as soon as you see it's not going to work, just give it up and try a different one. So we have 3 plus 0 would be 3. 3 times 3 is 9. 4, 3 times 4 is 12.
4.
So 3 works. So x is equal to 3 is one of our options. Now we have x cubed plus 3x squared plus 4x plus 12. So here is a good one that we can factor by grouping. So we could try it again and figure out what our factors of 12 are and do synthetic division again, but here we can factor by grouping. So we're going to group our first two together and group our second two together. And we need to take out a greatest common factor in the first one and take out a greatest common factor in the second one. So what can we take out of our first group of parentheses here?
X squared.
X squared. And then we're left with x plus 3. What can we take out of our second group of parentheses?
The 4.
The 4. And then we're left with x plus 3. The only way you can factor by grouping is if you get the same thing in the parentheses here. Because then one of our factors is x squared plus 4, so it's everything on the outside. And our other factor is what's in our parentheses that's in common, so x plus 3. And then we just set both of these equal to 0. So we have x squared plus 4 is equal to 0, and x plus 3 is equal to 0. So we get x is equal to negative 3. So we can add that to our list. And then for this other one, x squared plus 4 is equal to 0. We have x squared is equal to negative 4. If we take the square root of both sides, we get x is equal to plus or minus 2i. So I have to take out that I since we have a negative under the square root. So is this a real 0? If we have an I, is it a real 0?
No.
No, it's not a real 0, but this one, it doesn't ask us for real zeros. It just says all of the zeros, so we just have to include it in our list. So we have 2i and negative 2i. Our exponent, our highest exponent was 4, so we know we need to have 4 zeros, so we have 4. Any questions here? Ready to move on to the next set? All right, I'm going to go back through and do all the ones that I didn't get to do in class, so you guys have it. So for the first one, we are using the remainder theorem. So we can take -1, put it on the outside. Inside, we need to make sure we have all of our terms included, so we have an x to the 6th power. We are missing an x to the 5th power, so we need to make sure we have a 0 there. Then we have x to the 4th, we're missing an x cubed, so 0x cubed, and we're missing an x, so 0x. So now we can put all of our coefficients in the box. So we have 2, 0, 3, 0, -1, 0, and 3. Bring down the 2. 2 times -1 is -2. 0 times -2. 0 plus -2 is -2. -2 times 1, 2, 5, -5, -5, 5, 4, -4, 4, and 7. So our remainder is 7. So g of -1 would be 7. Let's look at number 4. So we do the same thing. We put a 2 on the outside, and we need to make sure that we include all of our coefficients, especially the missing ones. So we have 2, 0, 3, 0, -1, 0, and 3. Bring down the 2. 2 times 2 is 4. 4 plus 0 is 4. 2 times 4 is 8. 8 plus 3 is 11, 22, 44, 43, 86. 2 times 86 would be 172. And 172 plus 3 would be 175. So g of 2 is 175. Okay, the next ones we skipped were, I guess number 5, we didn't do it all the way. So we can try 1 first if we wanted to, but I know that that's not going to work, so I'm going to try 4 first. Inside of our box, we need 3, 2, negative 61, and 20. We bring down the 3. 4 times 3 would be 12. 12 plus 2 is 14. 4 times 14 is 56. 56 minus 61 is negative 5. Negative 5 times 4 is negative 20. 20 plus negative 20 would be 0. So here we have 3x squared plus 14x minus 5. 4 works as one of our roots, so we can have x is equal to 4 here. And then we can factor from here. So we can multiply the 3 and the negative 5 together and gives us negative 15. 2 factors of negative 15 that add to 14 would be 15 and negative 1. So we have x minus 1 and x plus 15. We set these both equal to 0. So x is equal to 1. Oh, I forgot. We have 3 as our coefficient, so we need to make sure we divide both of these by 3. So it does not go into 1 pretty, so we move the 3 out to the front. So this is 3x minus 1 is equal to 0, which gives us x is equal to 1/3. And then 15 divided by 3 would be 5. So since this is a whole number, we have x plus 5 is equal to 0. So x is equal to negative 5. So our remaining 2 zeros would be 1/3 and negative 5. All right, moving on. We did everything else on this page, so on to the next. Do you guys want to do 7 or 8? Because they're pretty much the same thing.
7.
All right, let's do 7. So we have 13 minus 5i. Here we need to make sure we distribute this negative to both things in our parentheses. So we have negative 16 minus 3i, and all we do is combine our like terms. So we have 13 minus 16, this is negative 3. Negative 5i minus 3i would be negative 8i. We need to make sure that this is in standard form, so we just have to have the real part first and then our imaginary part second.
Ms. Carver, is there a quicker part to get in the denominator when dividing? Like these numbers, these complex numbers?
So for like 15,
Yeah.
we'll get there. So I'm just going to do a couple more examples and then we'll get to 15 and 16 and 17. So don't forget your question. We'll come back to it. Let's look at number 9. We just have to make sure we distribute the negative 5. So this is negative 30i minus 20. We need to have this in standard form, so negative 20 has to come first. So negative 20 minus 30i. And then we can do...
You do 10.
Yes. So 10, we're just subtracting. So we have negative 7i plus 18 minus 6i. So we can get rid of these parentheses. We don't need them. And then we just combine like terms. So we have 18 all by itself, and then negative 7i minus 6i would be negative 13i. Okay, and out of 11, 12, 13, and 14, which one do you guys want me to do?
All
right. So for 11,
They're all
12,
just foiling, right?
they're all just foiling. So for all of these 11, 12, 13, and 14, they're all foiling. So we have to multiply our first terms. So this is positive 20i. Then our outsides. So this is positive 24 I squared, because we have an I times an I. Our insides would be negative 35, and then our last terms would be 42I, negative 42I. So we combine our like terms. I'm going to put the real number out front, so we have negative 35, and then 20I minus 42I would be negative 22I, and then a plus 24I squared. What happens to our I squared?
Turn to a -1.
It turns to a -1, so we have 24 times -1, which would make it a negative 24. And then we need to combine our like terms again. So we have negative 35 minus 24, which would be negative 59 minus 22I.
Yeah.
Okay, ready for the dividing ones, 15, 16, 17? Or you guys want me to do another foiling one?
Fraction ones.
All right, let's look at 15. So what do we need to do to get our complex number out of the denominator?
Multiply it by its conjugate.
Multiply it by its conjugate. Perfect. So what would the conjugate of 2 minus 4i be?
2 plus 4i.
2 plus 4i.
And same thing on top.
And we have to make sure we multiply it by the same thing on top. So on top, we're just going to FOIL. We have negative 16 minus 32i plus 6i plus 12i squared. On the bottom, we can FOIL, or we can just say that we have a 2 squared and a 4i squared, so it would be 4 minus 16i squared if you want to do the shortcut, so you would just square 2. So I'm just going to write it on the side here, but I'm going to FOIL it out as well. So if you can see that when we FOIL a number by its conjugate, we just take the first number, square it, keep the sign in the middle, and then square the second number, so 16i squared. But if we can't see that, we can just FOIL it out. So we have 2 times 2, which is 4, plus 8i minus 8i minus 16i squared. The 8i's cancel out, so then we're left with 4 minus 16i squared. And now we simplify. So on the top, we need to combine our like terms. We have negative 16 minus 26i plus, what does the I squared do to our 12?
Makes it negative.
Makes it a negative 12. So then we can simplify the top again by combining our negative 16 and negative 12. So this would be negative 28 minus 26i. And then we can't do anything else on the top, so we just leave it like that. And then on the bottom, we have our 4. What does the I squared do to our negative 16i? I squared.
I'll make it a positive.
It makes it a positive 16. So that I squared becomes a negative 1. Negative 1 times negative 16 becomes positive 16. So then we have 20 on the bottom. All of these numbers here are divisible by 2, so we could simplify. So we would have negative 14 minus 13i over 10. So this would be our final answer. Do you guys want me to do another one like that?
Yeah.
16 or 17?
17.
All right, let's look at 17.
I Are the denominators always going to be in complex form, or is it going to look different?
It'll always be in, it'll always be complex, yeah. That's like the whole point of it, is dividing by complex numbers. So it'll always be a complex number. So what would be our conjugate of negative 7 plus 5i?
Negative 7 minus 5i?
Perfect. Negative 7 minus 5i. So we have to make sure we multiply the top by the same thing. And then we need to FOIL the top and FOIL the bottom. So we have negative 70 minus 50i plus 21i plus 15i squared. And then on the bottom, we have 49. And then positive 35i minus 35i minus 25i squared. So our 35i's cancel out. On the top, we can simplify this. We combine our like terms. So we have negative 70 minus 29i. What happens to our plus 15i squared?
Now it's negative 15.
Now it becomes negative 15. And then we can combine our negative 70 and negative 15 to negative 85 minus 29i. So that's as simplified we can get on the top. And then on the bottom, we have 49 minus 25i squared. What happens to our 25i squared?
It becomes positive now.
It becomes a positive. So the I squared is multiplying it by a negative 1. So negative 25 times negative 1 becomes positive 25. 49 plus 25 would be 74. Yes. And then this would be our final answer. Any questions? All right, ready for 18, 19, and 20?
Yep.
Which one do you guys want me to do, 18, 19, or 20? Any suggestions? All right, let's do 20. So for 18, 19, and 20, to solve, we need to do the quadratic formula. In order to do that, we need an A, B, and C, so all of our numbers have to be on all of our terms have to be on the same side of the equal sign, and it needs to be equal to 0. So we can move this 7x to the other side, 7x squared to the other side by adding 7x squared to both sides. So it'll cancel out and give us 0 on the right. So we have 7x squared minus 6x plus 2 is equal to 0. And we need to do our quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. And now we just plug in. So our negative b, we need to change the sign of our negative 6 so it becomes a positive 6, plus or minus b squared, which is 36, minus 4 times 7 times 2, over 2 times 7, which is 14. So this gives us 6 plus or minus 36 minus 44 times 7 times 2, which would be 14 times 4, so 56 over 14. 36 minus 56 would be 20. So this is 6 plus or minus square root of negative 20 over 14 we can simplify the square root of negative 20 into negative 1 times 4 times 5. And the 4 and the 1 can come out. So the 1 comes out, becomes an I. The 4 comes out and becomes a 2. So we have 6 plus or minus 2I square root 5 over 14. Can we simplify this more?
By 2.
Yep, everything's divisible by 2, so we just divide everything. So we have 3 plus or minus I square root 5 over 7. And this is our final answer. So all it is here is the quadratic formula. Okay, since classes are shorter tomorrow because we have math, that means you guys have less time for your test. So we decided to take out some questions on the test. So you will not have any questions like 21 and 22. Don't worry about them. You won't have them on the test. So we still have 10 more minutes. Are there any questions you guys want me to go back and do now that we have time?
For tomorrow, how's the math gonna work?
All right, again, going back to the ones that we did not do in class, let's take a look at number 8. So here we need to make sure we distribute the negative to everything on the inside. So we have negative 8 plus 7I minus 15. We distribute the negative again. So negative 10I minus 56. Combine all of our like terms. So we have negative 8 minus 15 minus 56. This gives us negative 79. And then we combine our plus 7I and minus 10I, and this would be minus 3I. So negative 79 minus 3I. Next, let's look at 11. Here we have to FOIL. So 6 times negative 5 would be negative 30. 6 times negative 7 would be negative 42I. 2I times negative 5 is negative 10I. 2I times negative 7I would be negative 14I squared. Combine our like terms. Negative 30 minus 52I. This is minus 14 times negative 1, so this becomes a plus 14. So negative 30 plus 14 minus 52I. Negative 30 plus 14 would be negative 16. All right, so our answer for this one would be negative 16 minus 52I. Let's look at 13. Here we need to FOIL. We see that these two are conjugates, so if we want to, we can square the 2 and get 4 minus square the I squared would be negative 1, so this would be 4 minus negative 1, which would give us 5. So we know that we're going to get 5 if we want to do the shortcut, but we can just FOIL it out if we don't want to do the shortcut. So we have 4 minus plus 2I minus 2I minus I squared. 4 minus I squared would be 4 minus a negative 1. So this is 4 plus 1, which is 5. All right, 14. We have 9 minus 4I squared, which is 9 minus 4I times 9 minus 4I. 9 times 9 is 81. 9 times negative 4I would be negative 36I minus 36I plus 16I squared. So 81, this 16i squared is going to become a minus 16, and then we can combine our negative 36i minus 36i, and this would be negative 72i, and 81 minus 16 would be 65. So 65 minus 72i. All right, next let's look at 18. So we need to get all of our terms onto one side. I'm going to move these two over because I want positive numbers. So we have 6x squared plus 3x. So I'm adding 3x to both sides. So it'll cancel out. I'm adding 5 to both sides. So it'll cancel out. So plus 5 is equal to 0. We do our quadratic formula. So this is negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So this would be negative 3 plus or minus the square root of 9 minus 120 over 12. So negative 3 plus or minus negative 121. Oh, negative 111 over 12. 111 does not simplify. So the only thing we can do is take out an I. So we have negative 3 plus or minus I square root 111 over 12. All right, next we have 19. Everything's already on one side for us, so we don't need to move anything around. We need to do the quadratic formula, so negative b, since our b is negative 1, this just becomes positive 1, plus or minus the square root of b squared minus 4 times a times c over 2 times a, 2 times 5, which is 10. So this is 1 plus or minus the square root of 1 minus 20 over 10. So 1 plus or minus 1 minus 20 would be negative 19. So the square root of negative 19 would simplify to I square root 19 over 10. Okay, and that is everything. So again, you don't need to worry about the last ones or the last page. Sorry that this was so long, but I just wanted to make sure I did all of the problems for you guys if you want to do them when you're studying. And I forgot number 16, so let's go back, take a look at that one. So we need to multiply by the conjugate to get the I out of the denominator. So we have 1 minus I, and what we multiply on the bottom, we have to multiply on the top. So we need to FOIL the top and the bottom. We have 5 minus 5I minus I plus I squared over 1 minus I plus I minus I squared. So on the top, this simplifies to 5. This becomes a minus 1. So 5 minus 1 would be 4, and negative 5I minus I would be negative 6I over 1 minus I squared. I squared would be negative 1, so this would become a plus 1. So this would be 2. We can simplify this by dividing everything by 2. So we have 2 minus 3I. All right, and now that is everything for the review. And you will not have any questions like 23 and 24. So the last two sections on the review